everyone, and all are back again with a new topic on this remote sensing essential course. And this topic false topographic perception phenomena, and its correction is in two parts, and I can promise that it is going to be very entertaining for everyone, because this is the phenomena which is observed in satellite images of polar orbiting satellites, remote sensing data of hilly terrain. So, we start with a very famous footprint by astronauts on the moon surface, and when Neil Armstrong put his first foot on the surface of the moon, this is what the photograph which was shared with the world community. But it always perturbed me especially that why this footprint is raised. If you see here, the footprint is raised, whereas we know that on the surface of the moon the soil is loose, and if soil is loose, then if somebody puts a weight or his own foot on that, then it should create a depression rather than a raised ground, and that has really perturbed for very long time that why it has happened. But if we rotate this image which we are seeing, or this photograph by 180 degree, this is what we see. And then now the foot impression or the boot impression of Neil Armstrong is coming in correct perception. So, the first one, there is something wrong with the perception, whereas the second one gives the depth perception, which is the correct perception. So, we will be discussing in these two consecutive lectures that what is this phenomena and how it can be corrected, and whether it is also present in the satellite images, and then what are the correction techniques which might be available today. So, if we check even today on Google Earth, Google Map, on Google search engine, what we find that everywhere the footprint is shown as I have just shown, that is a raised ground, which should not have happened. But nobody has realized that what they are putting as a photograph is giving a wrong perception. Now, if you see this photograph of Neil Armstrong and the footprints which you are seeing here, like this one or this, they are all in depression. So, what was wrong with the first photograph of footprint, that is really a matter for concern. Here is a zoom part of this part, and this is what you are seeing, that footprint is in depression, which is giving a correct perception. If you open, say, Google Moon, like Google Earth, you are also having on the same installation Google Moon and Google Mars also. So, I would be also giving an example of Google Mars as well. Now, when we see and elsewhere in the literature or on the internet, and they say this is say crater. But now again, if it is a crater, then why there should be raised ground? Even if you see the small craters, apart from this big one, everywhere they are showing as a raised ground. In fact, when some meteorite or a heavy body falls on the loose surface of the moon, or have fallen on the loose surface of the moon, there should have been a depression rather than raised ground. So, that is again the same problem. And now, here when we rotate this image by 180 degree, that means upside down, if you see this this crater which was raised ground, and now this on the bottom right, it is giving the correct perception, including the one which is a basal, the biggest one, is also giving the correct perception. So, what is why such thing are happening? Let us see a few more examples, and then we will start explaining that why it is happening. Now, again another example of another crater on the moon surface, which is near the North Pole. Recently, lot of talk has been about the South Pole, because our orbiter was focusing, and lander and Pragyan also on the South Pole, but this is the photograph of North Pole, and what we see again a crater, though it is mentioned crater, but it is this does not look like a crater, it is a raised ground. But when we rotate by 180 degree, then we see as a depression, and it gives a correct depth perception about the moon surface. Now, let us come back to the earth, and this is a IKONOS image, a Landsat image, ETM image of Colorado River, which you are seeing in the blue line in the center, and north is upward. So, when this kind of arrangement is there, what we are seeing that the river is flowing on the ridge, it seems to, and giving a complete wrong perception, which should not have happened like this. But when we rotate by 180 degree, like now I have done it, see the north has gone downward here, north has gone downward and upside down, and now river 2 has gone into the belly, which is a correct perception. So, let us put both together, and this is what we observe, that on the left image, when north is upward, we are getting wrong perception, and when north is downward, we are getting the correct perception. And this is the location and of the image which I was showing, and this is a steady relief model which has been derived from digital elevation model. In few minutes time, I will be discussing also little bit about digital elevation model and steady relief model. So, what you are seeing here, and that in this one atlas they are showing the Colorado River in the depression, but in our image when we see here that it is not in depression. So, there has to be something wrong with the satellite image. But when you open the image from where I have downloaded, if you open the website of that one, it says the Grand Canyon, it writes a caption here about the the image, but there is no mention that this image has been rotated upside down, and therefore, though the river is appearing in the valley, but there is no mention that this image has been rotated. So, what is this false topographic perception phenomena? By now, you must have realized that optical remote sensing data and the images which I have shown of Colorado River and a few more we will be seeing from sun synchronous satellites or near polar orbiting satellite, which are the typical remote sensing satellite, when they are acquiring image of a rugged terrain like say Himalaya, then they suffer from topographic effects. So, what it means basically, if from the same satellite and even from the same sensor, if image is acquired from of a flat terrain like Indo-Gangetic plain or maybe some desert areas where shadows are minimum, and then you will not see false topographic perception phenomena. So, this FTPP is only seen in a rugged terrain, and that too with sun synchronous satellites. We will be also seeing what are other intricacies associated with FTPP. So, because of FTPP, what happens, as we have also observed in craters, in footprints and also Colorado River, that we perceive valleys as ridges and vice versa, and therefore, sometimes if we use these images, we might go for wrong interpretations of these images. So, that is the problem associated with FTPP. So, whoever is using images of a rugged terrain from these sun synchronous satellites or polar orbiting satellites must know that these images are suffering from FTPP, and either one technique which has come up already, that is by rotating 180 degree you can get rid of FTPP, and then you make the interpretations. There are a few more in FTPP correction techniques which have been developed, which I will be discussing very soon. And when FTPP is present, then this inverse, the appearance of inverse topography, which we have termed as false topographic perception phenomena in the year 1996 through a publication. So, first time this phenomena was accepted in the remote sensing literature, though people have been facing this problem. So, if you recall that since 1972-74 onward, the remote sensing satellite became available to the civilian community. So, between 1972 to 1996. During this entire period, remote sensing literature remained silent about FTPP, though users of these images of a rugged terrain were facing this inverse topography or false topographic perception phenomena. Now, what are the causes of FTPP? So, we will see one by one what are the causes. The first causes is topographic relief. If the terrain is flat, there are no shadows, then FTPP will not be observed. So, this FTPP is observed only in a hilly terrain or in a rugged terrain. And secondly, as a source observer position. This happens because the source is the illumination source which we are talking here, the position of the sun and where the observer is. So, what is happening in normal remote sensing images that these satellites are acquiring images at somewhere between 9:30 to 10:30 local time, and at that time the sun is in the southeast quadrant, and observer when he keeps the image north upward, that means the observer is also in the same hemisphere, that is the southern hemisphere. So, when this arrangement is there and that image if it belongs to a hilly terrain, rugged terrain, then we are bound to see FTPP. We will see further in this. And sun elevation and azimuth also plays very important role. As you know that this elevation when we talk about that means it from horizon, that is 0 degree, to the overhead, that is 90 degree. So, elevation, sun elevation will vary between 0 to 90 degree in a vertical plane, whereas azimuth is measured in a horizontal plane and it varies between 0 to 359 degree. That means total 360 degree variations are there. So, and fourth one is the viewing angle, from where things are being viewed, where the basically the position of the observer. And the next causes of FTPP is the hatching and engraving features on the slope. Because in hilly terrains these features are also present and they too create a depth perception or false topographic perception. Artists also and you know those who makes drawings and other, and if they want to give a 3D perception, they too uses these techniques, hatching techniques, to give a depth perception. I will be showing an example of that one also. Now we come to the satellite images, and this image is from IKONOS satellites of 1 meter resolution, and this is Tsangpo river. Tsangpo in Tibet, Brahmaputra is called Tsangpo in Tibet, and what you are seeing here in this image, that north is upward and river is flowing on the ridge. Now, geomorphologically, topographically, it is impossible that river flows on the ridge. River has to flow in the valley. So, why we are perceiving like this? So, when I was mentioning about the sun position or sun azimuth, that means when these images are acquired, they are acquired generally in the morning hours between 9:30 to 10:30, and at that time sun is in the southeast quadrant. And when this arrangement, and we are also observing north, keeping north upward. So, assuming that we are also situated in the southern hemisphere, sun is also in the southern hemisphere. So, when this arrangement is there, we are bound to see FTPP on remote sensing images of a hilly terrain like this image which we are seeing. But if I rotate this image, what happens basically that I have forced now sun to go in the northwest quadrant by rotating by 180 degree. And once I have rotated, that means now observer, that means me, is in the southern hemisphere and the illumination source, that is the sun, is in the northern hemisphere. When the illumination source and observer are in the opposite hemisphere, then we will not see FTPP. And this is what you are seeing, that now this Tsangpo river is flowing in the valley, which is giving a correct perception. Topographically, geomorphologically, it is correct. But what has happened, that north has gone downward. So, we have to, if we want to use these images along with some other data sets, then every data set has to be rotated by 180 degree, or we develop some other technique by which, in which we do not have to rotate, but we still can get rid of FTPP. So, those techniques we will be seeing also. Now, I am going to put both these the same image, one is north upward and another one on the right side is north downward, and the difference you can see, and the effect of FTPP also you can see. So, right side image does not have the effect because the illumination source and observer has gone into completely different hemisphere, whereas in the left image the observer and illumination source both are in the same hemisphere, and that image belongs to a hilly terrain, and therefore, we are seeing FTPP in the left image. Now, when you go and from where I have downloaded this image, this is the space agency or a space imaging company which has launched this satellite IKONOS. On their website also they have rotated the image without mentioning in the caption. So, they too have realized that if they do not rotate the image and they say that this is the Tsangpo river, then users of internet will feel that there is something wrong with the image. So, without mentioning in the caption, though they have rotated the image and realized that the FTPP exists, but no acknowledgement of that here. Let us take few more examples, very striking examples. If I say this is volcano area which is having a volcano, no one would believe, because here when north is upward, volcano is in the depression. It cannot happen. The volcano will always have raised ground. So, if I rotate by 180 degree, when north has gone downward, now I am seeing a volcano, and in correct perception I can see the lava flows also, and the volcanic neck also, and all the features, geomorphic features which are associated with volcano can be observed here. But in the previous, when the image having north upward, these features are difficult to observe, and therefore, I will make wrong interpretation. But here, once I have rotated by 180 degree, things have come into correct perception. And when I put both together, you can realize the differences between these two images on the left side or right side, though it is the same image, but the right one has been rotated upside down. Again, on the same side, they too have rotated without mentioning that why they have rotated. So, indirectly they are accepting that this FTPP exists, but no acknowledgement of that. Let us take one more example, like here in this image. If I say this is snow covered peak, then why is snow in depression and not on the ridges, which is when north is upward? But this is giving a completely wrong perception. But if I rotate by 180 degree, now I am seeing a snow peak which is really on the higher grounds. This is what has happened in real situations, that the snow will fall or will remain for some time only on the higher grounds, where on the lower grounds you can, and the glaciers and other features which are associated with this snow covered peaks are also there, or glaciated glacier geomorphology is also there. Now, this is the location of that Mount Rainier, of which we have seen the image. When we put both together, this is what we observed. On the left image, we are having FTPP, that image is suffering from FTPP. When image is rotated by 180 degree, north becomes downward. Now, image there is no FTPP effect. Again the same problem, they have rotated the image, but they have not mentioned that why they have rotated the image. I also gave example of hatching and giving features which gives us a depth perception. This is one example. This is not a satellite image, just simple drawing, and I have taken from a geomorphology book. And what we see here, that a valley is shown here, and then some tributaries are also there, and it is also giving a depth perception. But when I rotate this drawing by 180 degree, like I have been doing with satellite images, this is what has happened. That now on the right side, this sketch is showing a FTPP. So, artist also exploits this kind of thing using hatching and engraving features to give a depth perception. So, FTPP exists almost everywhere when these arrangements are there, that the viewer and the illumination source, if it both are in the same hemisphere, we are bound to see FTP. In paleontology also, and where people study fossils, and this is what they publish generally, this is what it is shown to us, but it might not be correct, might not be a correct one, though it is, you are seeing that a animal is shown here, which is trilobites here is shown, but when I rotate this image, then I see a complete and different picture, and this is what is happening, that this is giving a impression that this is a cast of a animal. So, there is a scenario of something like mold and cast, and what this is what we are seeing. So, even if I get in the field and the right image, if I rotate by 180 degree, I get the left image, and which gives a very good impression about the that fossil or that animal which was there. One more example we will see. These are the ammonites are there, again a different type of fossils, and of Jurassic, early Jurassic period are there, and what we are seeing again, they are nicely coming up in this photograph, but when I rotate this photograph by 180 degree, then it is nothing but the depression. So, which one is correct? Only the person who has collected or seen or taken the photograph can tell whether he saw the left scenario or on the right scenario. And therefore, in the books of paleontology, it is mentioned that the direction of light when the photograph is being taken must be kept from the upper left, that means from the northwest direction. So, this is what it writes, that directional lighting is also needed to show the fossil form. So, two examples of trilobites and ammonites which we have seen, that this light must come from the upper left. So, there is a direct acknowledgement that when the illumination source is in the opposite hemisphere, then we will see a correct perception. Otherwise, the fossil relief may appear inverted, and this is what there is a acknowledgement about this, though the exact terminology like false topographic perception phenomena has not been used. So, even in paleontologist, the light source while taking a photograph must be kept in the upper left corner, that is in the northwest direction. If it is kept in the southeast direction, then you would see a completely different form of fossil. Similar kind of situation can also come in the coins which has a lot of raised part and depression, like this one example I am showing here, and those who would like to test themselves, they can download such images of fossils or satellite images of hilly terrain or images of coins, and then if they rotate by 180 degree, not flip, I am saying it is not vertical flip, it is not horizontal flip, it is rotation by 180 degree. So, if you rotate, see the same coin looks completely different. It is a mold and cast kind of scenario because of suffering from FTPP, because of a particular direction which has been used while taking this photograph. And one more example, see here, this is 1 cent of US, and this is the situation which we see. So, this brings to end of part 1 of false topographic perception phenomena. In the next part, what we are going to discuss, we are so far what we have seen is about the phenomena, that why it is occurring and in which situations it is occurring. It is occurring in satellite images. I have shown several examples of satellite images. It is occurring in case of drawings. It is occurring, FTPP is seen with the fossils also, FTPP is also seen with the coins. One correction technique has already been discussed, that is the rotation by 180 degree. But when we use satellite images along with other data sets in GIS, then these things, and that means the rotation of 180 degree might not be possible. And therefore, it is very much required to develop some or discuss some other techniques which we have developed in recent past, so that without rotating the image, I should or we should be able to get rid of FTPP. So, this is what we are going to discuss in part 2. For time being, thank you very much.